This demonstration is entitled Social Network. We will demonstrate how to create a social network ontology and use it to classify people in our lives. And then the ability to use that ontology to ask very powerful, high-level kinds of questions. In this demonstration, we see a number of windows. In the upper right, we see a PowerPoint slide here showing a graph. More particularly, it's showing an ontology, something called Tom's Social Collaborative Network. This is a picture of an ontology reflecting of categories of people in my life. So I have a family category, a healthcare category, a friends category, and each of these are subdivided into subcategories here. And what I would like to do is to actually instantiate what you see in this picture here. So the first thing I do is I create an XML document that reflects this ontology you see here. I would then like to import this XML document into a TC-SQL soft schema. So I do that via the tool shown down here, XML to TC-SQL. You specify the name of a database, the input file here. A vocabulary will be the name of the collection of objects reflecting this XML document. And social network is the name of a namespace associated with this XML document here. Okay, so let's assume that I have actually executed this, which I actually have in the past. Let's also assume that I have taken a list of people in my life and I've categorized them into these various buckets. So now what I'd like to do is show you how to execute queries that will list the people in each of these buckets. So let's take a look at that here. So now we see a SQL Server Query Analyzer window here. And what we're going to do here, let's execute this query here. We're going to run a query here. And in this query, we're looking at a table called entity. And entity is simply a table containing lots of people that I know. And we have another table called entity classification. And that table binds the people that I know with these various categories here in my social network here. And here's the name of my social collaborative network here. And so if I execute this query, what we see is on the left here, we have a name column here, which will be the names of our categories here. And here are various people that I've assigned to these categories. So Attitudes Band is a rock band I was in, and here are some of the members of the band here, and you see I have an endocrinologist here. And notice down here I have a gastroenterologist. In this case it's not a person, it's an organization here. Okay, so this is all fine and dandy, but this is my social collaborative network. One of the things that is desirable is the ability to ask questions from an industry standard kind of ontology here. So again, this is my private ontology here. There are many industry standard ontologies that are out there. And if we look down here, we see an example of one. This is called SNOMED. It is one of approximately 150 ontologies in this collection of ontologies called UMLS. And so what I would really like to do is I would like to be able to ask questions from this perspective, from ontologies that are considered industry standard. So one of the things that I did here, you'll notice a box here that says NLP, natural language processing. It's checked off. So what this does is the following. Let's go back to our PowerPoint slide here. It applies natural language processing to every node here, the name of every node in this graph here, and what it's doing is it's trying to associate the names of the nodes here with names in other ontologies. And so I'm using an NLP tool called MetaMap. It's used to do NLP with respect to the healthcare field. So I will apply NLP to each node here, and then I will import the resulting XML here. And so what happens here, because what is returned from the executing this NLP is an XML document. And so in this next step, what I want to do is take the result of the NLP for each of these nodes here and attach it, this structure, as a child of each of these nodes here, and then provide the ability to query on this grander structure here. So let's take a look at that. So what you saw in the query over here were the list of people in every node here. Now I mentioned this is an NLP tool applicable to healthcare, the healthcare field. Now you'll notice that a number of these nodes here, you can pretty much guess if I apply NLP to it with respect to healthcare, nothing will come up. But in fact, when I'm trying to bind it to an industry standard here, there are clearly some nodes here. Endocrinologist, for example, is clearly a healthcare node here, and so you would expect to find something with respect to that. So let's look at a query here, which now queries with regard to industry standard kinds of ontologies here. And I won't go into the details here, but when I execute it here, what we see here are the names of the nodes that we saw in our picture here. And these happen to be the ones that when I executed NLP, happen to find a match. So these particular nodes here had equivalents in these industry standard ontologies here. And so we find the various people I had assigned. So if I wanted to ask a question from an industry standard perspective, these are the people that show up with regard to this industry standard ontology here. Now, let's take a closer look at what happens. Let's take a closer look at the association between the nodes in my private ontology versus the nodes in these industry standard ontologies here. I wrote a query here, and I won't bother going through the details here, but to suffice it to say, when I execute it here, what we see is a column here called name, and this happens to be the names of the nodes here in my private ontology here. And then we have another column here called ontology term, and these are the terms that were matched in the industry standard ontologies here. We've got another column here called ontology here. I mentioned UMLS has 150 different ontologies associated with it here. And so we see that this notion of a dentist here shows up in a whole bunch of ontologies here. And now the notion of family shows up in other ontologies here. And every ontology has a local code associated with that ontology here. And so you get an idea of how to associate private information, nodes in a private ontology here via NLP provides a way of associating the nodes of a private ontology with an industry standard kind of set of ontologies.